Number 9. Find the reference angle and the angles with that reference angle in the other 3 quadrants. Find a positive and negative coterminal angle to the original angle. Okay, so 0, 90, 180, 270. This one is positive, so I rotate in this direction. And 285 will be just a little bit more than 270, and it doesn't have to be perfect. Just something like this. Okay, the reference angle is the angle always with whatever angle you have in the x-axis. So how much this is. And I know that it's 15 degrees between those two. So it's going to be 75 here. If you want to, you can do 360 minus 285. I don't love that, but a lot of people love that. Okay. Now find the other 3 quadrants. So I'm going to extend my arrows. Hopefully they'll look okay. Nope, 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 definitely not. Yeah. Yeah.
That makes sense. That's a good question.
Okay. Now my original angle is in quadrant 4. That means I don't need to find quadrant 4. I already know that one's 285. I need to find the other ones. Shh. And I know this one has to be 75 because it has to have the same reference angle and it's in quadrant 1. So that's 75. Quadrant 2 is going to be 180 minus 75, which is 105. Quadrant 3 is going to be 180 plus 75, which is 255. Okay, and it said find a positive and negative coterminal. So I'll start with the positive, 360 plus 285 is something. Don't tell me. 645? Yes? So 285 is also 645. But if I go the opposite direction, I can't. I'm not smart enough to. Oh, duh. I feel so stupid. It's also negative 75. Of course it is, because anyway. Wow. Wow, that was my dumbest moment of the day, I hope. Okay, so this little angle right here is 285. It's also 645, and it's also negative 75, and it's also infinite other things. Okay, any questions about this warm up here? Anything before we leave it? Other than how to add and subtract in your mind. I mean, I can't do that either, apparently. Don't ask how to add and subtract in your mind. Is that what you're gonna? Oh, sorry. What were you gonna say, honey?
One, Q two, Q3, Q4, it's really hard to calculate.
The remembering or the adding and subtracting?
Well, that too, but remember.
I mean, you just gotta like put it on a little note card and just look at it a lot of times during the day. What? No, no, no. Like actually, like you know,
Look at it.
throughout the week. Yeah. Like in my stats class, when they have to memorize something, they take a little piece of a note card and put it like in their phone case because the phone cases are clear and like make themselves look at it several times a day. Okay. So believe it or not, I don't think we have anything more in the packet today. Hey, don't make this circle tiny. You don't have to make it as huge as me, but you don't have to just don't make it tiny. Oh, you're the best. Okay. So today is the day where we're going to actually figure out what the radians mode is on your calculator. So your calculator, all year, it's kind of been lurking out there in radians. I mean, guys, so I say, make sure your calculator's in degrees, make sure your calculator's in degrees. After today, you're actually going to have a little bit of a thought process before you do a problem about whether or not your calculator should be in degrees or radians.
I don't like that.
It's, yeah, because I said you have to have thought process. Yeah, I know. Okay. In number 60, my goal is for you to understand exactly what a radian is. So in number 60, we're going to call this defining a radian. Defining a radian. Okay, so get whatever circle you are happy with. Or, you know, are okay with, can live with. And then what I want you to do is do your best drawing in of the radius. So okay. It should be no surprise to you. I hope that this spot right here is 0 degrees. Did you guys all know that this is 0? 90, 180, 270. It's also 360. It's also 720. It's also a lot of other stuff. Okay. What I'm going to do first is I'm going to estimate what 1 degree would be. And I'm going to estimate it because if I draw it, I think it'll look terrible, but I'm going to give it a go. And you guys just copy whatever I have here. So 1 degree should be like right here. but I'm not going to draw 1 degree. I'm just going to draw something that looks like it could be 1 degree because otherwise it'll just overlap. Okay. How many of those 1 degrees theoretically would it take for me to get around the circle? 360. So there should be 360 of those little dudes all the way around. Are we going to draw them? Absolutely not. Okay. Are you comfortable with what we have so far? We have a circle. We drew in its radius. We declared our start is 0, and then we just sort of eyeballed what 1 degree might look like. Okay, my goal is to contrast that with what a radian is. So you're going to get to watch me struggle, and this is going to be fun for you. So a radian equals radius angle. So the word radian means radius angle, and this is going to be fun. So watch your teacher just completely screw this up. It's going to be awesome. What I'm going to do is I'm going to take a piece of yarn and I'm going to attempt to cut it to be the length of the radius, except for that she's wiggly here and it's rough. No, no yarn for you. It's yarn, honey. Okay. Now, let's just go with that. I'm hoping it's okay. All right, what I'm going to do is the reason I'm using yarn is because a radius angle is how much the angle is when you bend the radius around the circle. So I'm putting the tail of it here at 0, and I'm bending it around. And what I want you guys to do is just estimate where this would be on your circle, right about here. If your circle is circular. And I want you to label that 1 radian. I want you to really think about the difference between a degree and a radian. It's like an inch and a foot. Oh no, we just crossed into chemistry. This is going to be like unit conversion. It's really not bad though. Okay, but do you see the difference between a degree and a radian? Degree is little, radian is big. Does a radian look to you like it's about 60 degrees-ish? Okay. All right. So now we're gonna try this again. Oh, how fun for Mrs. Talbot. 2 radians. 3 radians. But here's the thing. It's not perfectly 3. So there's 180 degrees. Does anybody know? Does anybody know any number that's just a tiny bit over 3? Well, yes, but a famous number that's a tiny bit over. Yeah, nice. Let Connor have it. Okay. This is pi radius. So it takes pi to get halfway around the circle. Okay, now, whoops, I got to go to 3, not pi. 4. 5. 6. And this is going to be 2 pi, because 2 pi is about 6.28. Okay, this spot here is 0 radians. It's also 2 pi radians. 0 meaning the start, 2 pi meaning 360. It's also 4 pi and 6 pi and 8 pi, and negative 2 pi and negative 4 pi and negative 6 pi to infinity. Okay, what I need you to take from this is that pi is not the same thing as that thing that you get from nations. Okay, we love the thing you get from nations, but that thing is the whole circle usually. I have a pi story about my mother, by the way. I'll tell it in a moment. So pi is only half of the circle in math, not the whole circle. So you can't be like, oh, pi is a pi, like a baked good pie. It's only half of a baked good pie. 2 pi is a whole pie in a baked good. Right. So pi is halfway, 2 pi is all the way around. It's kind of sad. Because one of them has an E on the end. It's not the same word. Okay, my mother, she goes to nations. My mom lives in Michigan, by the way, and she likes custard pie. And they don't have a place with good custard pie in Michigan. She comes out to visit me every summer. And her birthday is June 26th. So I take her to nations on June 26th on her birthday. She orders 2 pieces of pie. I don't know if you've been to nations and seen the size of 1 piece of pie, but 2 pieces of pie is actually pie. Because their piece of pie is a quarter of the whole pie. My mother took down 2 entire pieces of custard pie. So she sat there and we were like, Mom, you could take one of those home in a box. And she had her fork like this and she goes, we'll see. And then like 5 minutes later, it was all gone. So it's our family joke now about my mother and the pie. We'll see. She can take down pie like no other. I think while you're setting up your notebook, you should discuss your favorite type of pie. Mine is lemon meringue. I also really like key lime pie, chocolate mousse pie with an Oreo crust. Anyway, sorry, I'll stop now. Sorry. Just gonna make everyone starving. Yes,
Like the second to last day, so you think the class will pop up?
probably not. Probably get in trouble.
I just will, yeah, one more. I think I'm very.
We have a final exam the second to last day of school. But the last day of school, I believe this year, you just come and like do yearbooks and clean your folders out and stuff. It's supposed to be fun.
So honestly, if you gave me homework the day before summer, I wouldn't have do it. So I mean,
I'll give you a final exam review packet like the week before, and that's it. Don't take AP stats then.
by, by,
APs. Yeah. All right, you guys, we're moving on. Number 61. Assume the radius of a circle is 1. And we've been working this way for quite some time. It's called the unit circle. So screamer is the unit circle, radius of 1. And here's something that you might have thought about, maybe not in middle school, but maybe you did. The circumference formula. Does anybody remember the circumference formula? Jacob did. 2 pi r. Yeah. Okay. The circumference of a circle is 2 pi r. And you might just accept that your math teacher is not feeding you a bunch of hooey and be like, just memorize it. Okay. But now you can kind of see where it comes from. If the radius is 1, then the circumference is 2 pi. 2 pi radians takes 2 pi to get around the circle, just like what we learned. So there's where we just proved the circumference formula. Woo! Okay, now we're going to do convergence. This is like chemistry, but it's kind of like baby chemistry. We're going to make ourselves a little fact. Pi radians equals 180 degrees. But the main thing here is that we need to do this with no calculator. So it's not the conversion, it's the fraction that we need to work on. Okay, so put this little box here. This is the fact that you're going to use for all these problems. There's only one fact. So you don't need to know moles and all that. It's just pi and 180. 6.02 times 10 to the 23rd. Avogadro's number. Molarity. Avocado's number. Anyway. Okay, so you start with 50 and you go times line. Okay. 50 degrees is on the top. So that means you want to put the degrees on the bottom to cancel it out and radians on the top. Well, it depends. If you start with degrees, then yes. Okay, and so you have 50 over 180. And then you reduce the zeros. 5 pi over 18. So 50 degrees on the unit circle is at 5 pi over 18 radians. Yes, honey? Yes. Yeah. Okay. 200. Let's go again. 200 degrees times line. Okay, you have degrees on the top, so you want to put degrees on the bottom to cancel it out. Pi 200 pi over 180. Okay, now if I'm doing this problem, I'm going to simplify it in 2 steps. You can do it in 1 step if your brain is that good. Mine is not. So the first thing I'm going to do is reduce it by a factor of 10 by canceling out the zeros. And then I notice they're both even, so I'm going to divide them both by 2. So 200 degrees, it's at 10 pi over 9 radians on the unit circle. Okay, 640. 640 times line. Degrees is on the top, so I want degrees on the bottom to cancel. Pi on top. Okay. So do you guys like canceling out the zeros first too? Okay, so 64 pi over 18. Divide by 2, 32. Whoa, I forgot the 2. Just disappeared. 32 pi over 9. Are there any questions about this? Okay, so now we're going to go backwards. It's fine. It's not bad. It's fine. Yes. Uh-huh. Okay. Yes.
Is there a difference when it's like 3 pi radians and 9 radians?
Yes. Um, okay. So start with pi over 2 times line. And this is a little different because we did times line before, but this one already has a line in it. So you want to make sure your line goes right next to your other line. On this one, the pi is on the top, so we want to put the pi on the bottom to cancel and the 180 on the top. What? Okay. All right. So pi's cancel. 90. So it's division. Yeah, yeah, yeah. Oh, yeah, yeah. No, division, division. So pi over 2 radians is 90 degrees. Now, I want you to think about that, if that makes sense to us. Pi over 2 radians, I want you to think of that as half pi. So if this is pi over here, does it make sense that half pi would be right here? Yeah. Okay. 3 pi. 3 pi times line. Now there's no fraction here, so just pretend it's over 1. Pi on the bottom to cancel. 180 on the top. Okay, now here's my question. Without a calculator, how would you do 180 times 3?
And carry it. Yeah, two.
Okay, I like it. So some of you guys would do it like this. 0 times 3 is 0. 8 times 3 is 24. 3 times 1 is 3. Plus 2 is 5. Okay. Um, some of my students last year told me they learned it like this. Never seen this before? I don't care how you do it, but you're going to have to do it. Also, what you could do is do 18 plus 18 plus 18 and then add a 0. Okay, anyway, 9 radians. This one is spicy. Okay, let's talk about why this one's spicy. And this one would require a calculator. I couldn't give you this one on a quiz if I wanted it to come out the way I want it to. So don't worry about this, but it is spicy. Okay, so you have 9 times line. And then you're thinking to yourself, well, right, where do I put the pi? Because there's no pi to cancel. Well, you have to think to yourself that we write the word radians after it, and we would write the word radians after pi, so that needs to be on the bottom. Okay, I'll write it out. Nine radians times line. What I'm saying is, if you don't have the pi, include the units. That way you can see what to cancel. Cancel out radians, even though there's no pi on there to cancel. Okay. For this one, you would do 9 times 180 over pi on the calculator. Pi button on this calculator is located right above the exponent over here. So you go 9 times 180 divided by pi. And it's about 515.7 degrees. Can degrees be decimals? Absolutely. Okay, we have one more problem, then we're done. Okay, if you guys could keep your whining to a minimum. Hi.
Yeah, it's like a whole bunch of symbols, like Egyptian tombs.
That's so cool.
Scary.
Just, Einstein math. It's when all math turns to symbols. Here's the thing. If you guys really struggle with radians, I taught you how to convert it. So you could make everything into degrees if you wanted to. Do I suggest you do that? No, because it's going to take you twice as long to do everything, but you could. It's there for you. Degrees are always there if you love them. Now, the thing is, Mr. Guinan and Coach T, in both of the pre-calc classes, if Mr. Guinan teaches pre-calc, I know whoever teaches pre-calc will do it, are going to give you time radian quizzes where you have no calculator. There's a timer going on the board and you have to do this in your head. So now's the best time to take the time to make sure you know what you're doing before you get the time stuff.
When if you're going with
Yeah. It'll be great for you. maybe. So after you make this super awesome thing, if you could get your calculator into radians, please. I've never wanted it in radians before. I know. I know. You can no longer be ignorant about what mode your calculator's in.
Yeah.
Mode,
Mode,
but
right?
mhm.
There's mode again. Upload. Enter.
Yep.
Enter.
And then second mode will get you out of it. Oh, good stuff. Good stuff.
You can play games with calculator. I heard you can, like you can play, you have a little old.
Oh, yeah, yeah. I don't, but you can. There's several different ones.
You know how they did that?
Nope. I use my calculator for work.
Yeah, I'm sitting there on my.
Yeah.
Oh, I forgot the X. I thought I was going.
Okay. Now you can still keep writing, but I'm going to count fractions like your babies. And please do not think I'm not trying to be condescending. I promise. This is not me being condescending. I'm just gonna do this because people don't love the fractions. And so we just need to get the comfort level up. 1 pi over 4. 2 pi's over 4. Do you see it? 3 pi's over 4. 4 pi's over 4. 5 pi's over 4. 6 pi's over 4. Oh, 7 pi's over 4. 8 pi's over 4. See, wasn't that helpful?
Wait, what is the one that 4 and 4, like on the left side, like the pi thing? You take pi by itself, so the refund is like.
It's just 4 pi's over 4.
Wait, then the one on the left, like the second one. Pi over 2? Yeah.
That's 2 pi's over 4.
Oh.
Okay. All right. So I want you guys to get your calculator. And mine says degrees right here, which is what I do not want now. I want it to be in radians. So I'm going to hit the mode button, which is right next to the blue one. I'm going to find radian, hit enter. And then I'm going to go second mode, which is quit, which gets me back to here. Okay, so we're going to fill out our table using our calculator. It should say radians up here now. And from this moment forward, you are now responsible for what mode your calculator's in. You need to know if the problem has degrees or radians in it. Okay, sine of 0 is 0. Okay, great. Sine pi over 4. Again, the pi button is located over here above the exponent. You just have to hit second and then the caret. Okay, now this should be comforting. Have you seen that number before? Yeah, okay. So, does anyone want to venture a guess as to what degrees pi over 4 is? 45, yeah. Well, just from remembering that the area code thing, it's okay. Okay, now do sine pi over 2, and then just keep going. Fill in your table. Okay, well, I'm hoping that I'm comforting you in the fact that the sine wave did not change. He's his usual self. It's just that we changed the units. It's like changing from inches to feet on the x-axis. No big deal. So 0 is still 0. Pi over 4 is 0.707. It's just going to be right underneath the 0.75. Pi over 2 is 1. 3 pi over 4 is 0.707. Pi is 0. 5 pi over 4 is negative 0.707. And then can you see where it's going? So this one's going to be negative 1, negative 0.707, and then back to 0. And there's your full cycle of your sine wave, just in radians. Okay, I have 2 more things to show you before I'm done. Yes. Oh, crack myself up. Okay, first one is the agenda. We did 60 to 64, how to make a radian, and we're going to have a rad time. And homework tonight is 65 through 68. And here's your next pickup line. Hey girl, is that a TI 84? Nice. Okay. This is that a TI 32XS? Um, okay. Last thing I want to show you today. We have a quiz Friday. These are our topics. First topic is Pythagorean identity. That was like number 15 and 16 on your weekend homework worksheet. Make the triangle in the appropriate quadrant, do Pythagorean theorem, blah, blah. The second one is sketching an angle in standard position and finding the reference angle. That's as easy as it sounds. The angle on the quiz is not in the first quadrant this time, though. No, I'm not telling you the quadrant.
Oh.
And then last is converting an angle from degrees to radians and radians to degrees. So that's what we just did today. The 180 to pi or the pi 180. Okay. So you already know all of it. I mean, you already, okay, no, that's a word. You already been exposed to all of it. Then we have to get the rest of the week to know it.